What's up? It's your boy, the network. Today's topic is configure and verify NTP 6.4a, section 6.4a, NTP master client version 3 and version 4. This is a topic in the CCNP route exam. It'll be known as CCNP enterprise exam. Let's go ahead and take a look at the exam blueprint to see where we came from and where we're headed. Hashtag labeveryday. Go ahead and visit labeveryday.com and maybe in the future networkbro.com. Implements the Cisco IP routing. It's exam code 300-101. It'll be known as exam code 300-401. We finish up the section 6.3b timestamps of logging, right? Well, we wrapped those last sections up. We did all of these 4 sections in one video. Today, we are going to cover NTP. We're going to cover master client version 3 and version 4. After that, we'll do authentication. So what is NTP? Obviously, it says right there, network time protocol. It's a way for us to synchronize our time on our network because we'll have several devices, right? And each of one of them has the clock, has the time, right? Well, how do we know which one will be the correct time, right? Because you could have, if you look at your clock or on your phone, right, you might have a time, but if you drill it down to the seconds and ask somebody else for the time, they might not have the same exact time, right? Like down to the seconds, right? This happens with everything, with every clock. You can look at the clock on your car, the clock on your cell phone, somebody else's cell phone, the clock on the VCR for any of you older people that are watching this, right? The clock on the VCR always went to 12 o'clock, right? And flashed all the time, right? But this can be an issue because obviously if all of our times are not synced, we're not agreeing on the same time. And this can cause a problem because let's say we have some time-based ACLs that we need to keep accurate. We did, remember we did a video on time-based ACLs, right? That's dependent on the time, right? If we're looking at what we did in last video, we did logging, right? Let's say if we look at some logs or some assist logs, right? And we see some timestamps that maybe it was like, wait a minute, the router went down at 3 o'clock. We didn't turn this thing up until like 6 o'clock or something like that, right? Well, the time is off, right? So we need to kind of make our time very accurate. Let's head to the slides for the official definition. Okay, so NTP is a networking protocol for clock synchronization between computer systems over packet switched variable. Just like I said, it's a way to synchronize our clocks. Make sure everybody got the same time, basically, and we all agree to it, right? The goal of NTP is to ensure that all computers on a network agree on the time, since even a small difference can create problems. For example, if there is more than 5 minutes difference on your host and the Active Directory domain controller, you will not be able to log on your AD domain, right? So obviously, if the time is wrong, it can cause problems on our network. We need to have accurate time source rather. Let's discuss NTP stratum. NTP determines the reliability of a source with the concept of stratums. Now, what's a stratum? A stratum is how accurate the time is, right? Well, you would probably think, okay, well, let's just make the best stratum, right? Well, there's a couple of levels of stratums, right? You look at this chart right here. We have these clocks that you see right here, right? This would be considered stratum 0. These would be like GPS, atomic clocks. If you know what atomic clocks are, that's like the most accurate clocks that are out there in the world, right? There's one atomic clock. I can't remember what the location is, like somewhere up north or something, but it has the most, like it has a bunch of gears and stuff, right? It's the most accurate time in the world, right? And there's a couple of them that are located throughout the world, right? You can have your clock synchronized to the atomic clock. That would be stratum 0. There's no 0 there, but that's where atomic clocks and GPSs would be, right? Now, stratum 1 are clocks that are 1 hop away from the atomic clock. 1 hop, right? So this is stratum 1, and so on and so forth. The further away you are, the further away you are, the higher your stratum is, right? And it'll be a number from 0 through, I believe, 15. Yeah, I believe 0 through 15, right? But on Cisco iOS, you can only set 1 through 15 because why? Cisco devices are not atomic clocks, so they can't be stratum 0. You can only set it to be as high as stratum 1, right? The lower your stratum, the more accurate the time is, right? So as you can see right here, Stratum 1 is a device that is directly connected to an atomic clock. You have to be directly connected to it to place it in Stratum 0. So unless you have a Cisco iOS, a Cisco device with a fast Ethernet plug or some kind of plug that's directly connected to an atomic clock, it's not very wise to set it to be a Stratum 1 clock or a Stratum 1 device rather, right? Stratum 2 is one hop away from that. Stratum 3 is 2 hops away, so on and so forth, right? So these are Stratum 1 clocks or Stratum 1 devices, Stratum 2 devices, Stratum 3, so on and so forth. The lower the number, the more accurate the time is, right? Or more authoritative the source is what we would say. We can configure an NTP or an iOS device to be an NTP server or an NTP peer, right? Or actually NTP master or NTP peers rather. So an NTP server is also referred to as an NTP master, right? To configure the master, you must set the stratum level, right? And we talked about what the stratum levels are. The default for Cisco devices is 8. Now you would think, okay, well that's not very well. That's just the default. They probably think you ain't gonna be that close to an atomic clock, but the default is 8. And you can set the time range or set the range to be 1 through 15. Use this command. It's simple. Just NTP master, and then you put the stratum number, right? You can consider that device to be the master on your network. Now, everybody else, you will set them to be peers, or you could set them to be just servers. Now, servers are, now I know it says here, it seems kind of contradictory, right? It says servers are also referred to as a master, right? But we will have a master like a master. It's just the main master clock on your network, right? After that, you can have servers, right? And then everybody else will be synchronizing their clock to the servers. The server will synchronize his clock to the master. So I hope that makes sense. I hope y'all wrote that down. So if we go, in order, the master is at the top, right? Then we have our servers. Then we'll have peers below them. They synchronize to the master. They synchronize to the servers. You could have 2 or 3 servers, NTP servers on your network, right? But they will all have to synchronize their clocks to the master, right? You can set up 2 or more NTP servers as peers. We're not going to do that in the lab today. We're going to fire a Boson Netsim and play with it, but we're not going to be dealing with peers. We're going to be dealing with servers. So this allows them to exchange NTP information to configure a peer. You just do NTP peer and then the IP address of the peer, right? What we're going to do is we're going to be setting servers. So clients, there are 2 ways to configure a client. You can either statically configure the server to that the local router should synchronize from, or you can set the local router to listen to NTP broadcasts on an interface. These are the ways to do it. You set a server. I believe this is the way we're going to do it. You could do it this way as well, NTP broadcast and then client. This is the way we're going to do it see, notice that this is a way to set him as a client. You can set a server to be a client of a master, right? So think of that hierarchy, right? We got the master, servers, and below them are peers, right? We're not going to be setting peers in the lab we're going to work with today. So Cisco iOS, you can use 3 versions of NTP, but version 3 or version 4 are the most commonly used. Version 4 supports IPv6 because backward compatible with version 3. NTP 4 also has DNS support for IPv6. NTP version 3 uses broadcast messages, whereas NTP 4 uses multicast. And then NTP 4 also does do public key cryptography, so it's more encrypt your keys, basically encrypt your NTP broadcast. Remember now, you can hack a network via NTP. If your time is off, you can access a network device, change their time if it's not secure, and then change the time, and then just kind of like access servers if they have time-based ACLs. There's different ways to hack a network. NTP could be a flaw if you don't, set it up right. You could configure the version by just doing NTP server and then the IP address, and then do a version 4. In this lab, we're not going to deal with versions. I'm just going to show you all the configuration. You just type in version 3 or version 4 after you do the server or the peer's IP address. These are some show commands. Show NTP status, associations, association details. We'll deal with all of those. I don't think we're going to do any debugging. If I remember, we'll try to do some debugging to see if it works. I'm not even sure. This is a simulator, remember? It doesn't have every single command on here. But I think all these show commands will work. I'm not too sure about the debugging command. So let's go ahead and fire up Boson Netsim and play with NTP servers and peers. All right, here's the lab we're going to be working with today. We got router 1, router 2, and then we got these 3 switches right here, right? One will be the master. Two, we're going to configure him, I believe, as a server, and then we'll configure these guys as servers as well. But we could also configure them as peers, but I don't believe peer is supported in this simulator right here. Again, there's the topology. I also forgot to mention that router 1 and 2 is configured. We'll be sitting in OSPF. It's already configured here. Here are some basic commands, the commands we went over, including the show commands that we just talked about. There's also show clock, which I'm pretty sure y'all know about. We did that with, I believe, the syslog video. Here's the IP addressing guide. If you want to pause it, freeze frame it, there it is right there. And let's go ahead and do that. There's some basic questions, I believe, at the beginning. Task 1 says to configure the NTP master. This task involves observing Ntp, configuring an Ntp master device, and configuring the clock on the Ntp master. 1. Are any of the devices in the topology currently running Ntp? I don't believe so, but let's see. Router 1, let's start with router 2, right? Enable. How do we do that? We just do show Ntp status. Nothing there. Let's go to router 1. Enable, show Ntp status. Nothing there. I'm not going to deal with those guys. I'm pretty sure they don't have it either. Question 2. On router 1, let's go to router 1. Configure the date and time to be June 25th, 2014, 8:01. Alternatively, you can use your local date and time. We'll do that. Let's set my local date and time. Today is August 27th, Tuesday, August 27th, 11:43 p.m. So we're going to say clock set. We're going to set the hours is going to be 23:44. We'll say 45. And the seconds is 00. They want the day is the 27th. It's August 2019. There, we set the time. We can do a show clock, and there's the time and date. Okay, on router 1, display detailed information about the date and time. What time source is router 1 using? Detailed. Now, we just did regular. So you can also do a show clock detail, right? Now it says here, time source is user configuration. How? Because we set the time, we configured it. I'm the user, I configured it. That's basically what that means, right? What time source is router 1 using? The time source is myself. That's basically it. On router 1, configure the router be the NTP master. Use a stratum of 3. How do we say we're going to configure the time? The master. We said NTP master, and then we set the stratum level, which could be 1 through 15. The default is 8. We're going to go global config mode, NTP master. We said the stratum of 3 he wants, and that's it. Carriage return. So now he is a NTP master, right? Router 1 is now an NTP master. So now everybody else that want to know the time, they need to ask me, but we need to set them up to ask me right now, right? Router 1, on router 1, display detailed information about date and time. What time source is he using? So now we're going to do the same thing. Show clock detail. Now time source is NTP. Right? There's the time, UTC, right? On router 1, display the status of NTP. What is the status of the clock and why? So we do that with show NTP status. Clock is synchronized. He said, what time source is router 1 using? Where's the source? Source is, do we see anything about source here? Reference is 127.1.1. So I believe that would be myself. On router 1, display Ntp Associations. So show, that's easy, right? Ntp Associations. What is the status of the clock? Status is, or what stratum is the reference clock and why? The stratum is 2. Why? Didn't we set it as 3? Well, let's read this. I wanted to pull this up because this is a better explanation. I didn't have this on my slides here. Based on the output, you can determine NTP on router 1 is configured to synchronize with an NTP reference clock of local, right? So that lets us know it's local. And that the configured NTP master for router 1 has an IP address of 127.127.1.1 and a stratum of 2. Because NTP on router 1 is synchronized with its own internal clock, local, the stratum of the internal clock must be configured with a must be configured higher than the stratum at which NTP master is running. The IP address of 127.127.1.1 is a reserved IP address that indicates the local clock. So this IP address lets you know it's the local clock. Now that I didn't know. So that is a reserved IP address. And the stratum of the internal clock must be configured higher than the stratum at which the NTP master is running. So if we set the master to be 5 and we are the master, then that means if the stratum will be 6 locally, because it says here the stratum of the internal clock must be configured higher than the stratum at which NTP master is running. Task 2, configure NTP clients. This task involves observing NTP and configuring 4 NTP clients, which are going to be these guys right here, right? Because he's the master, router 1. On router 2, go to router 2. Configure NTP to use router 1's serial 000000 interface to obtain the date and time, right? So how do we do that? We're going to go to global config mode, I believe, and we're going to say NTP. What are our options here? We're not going to set him to be a master, right? Because he is the master. So therefore, we're going to set him to be a server, right? You would think he'd be a peer, right? But peer is not even supported on this simulator. So we're going to set him up as a server. And then the IP address of the peer will be who we're going to synchronize our clock to, the master, right? So what's the IP address of router 1? I don't even know. So let's go ahead and router 1. He said to use serial 00 interface, right? So let's just go to router 1 and figure out what that is, right? Go to router 1. We're going to say show IP interface brief. Serial 00 interface is 192.168.1.1, right? So we're going to go back to router 1. We're going to say 192.168.1.1. What else we got left? We can set a key, an authentication key that we will discuss in the next video, which is NTP authentication, right? So that's all we're going to do for that guy. Oh, I guess I forgot to show y'all the date and time. You know what? Now that we've done that, let's go ahead and let's get out of this, right? Let's do a show clock real quick. And you see right now it says March 1st, 1993, right? If we just keep doing show clock, we're just going to keep doing that, right? We keep doing the show clock, right? It takes time to synchronize. That's the thing with NTP. It's like I'm not too sure how often the NTP broadcasts go, right? But remember, version 3 is NTP uses multicast, right? Version 4 uses multicast, the IPv6 version. Show clock. It still says 1993. There it is, right there. Tuesday, August 27th. See how long it took before we got it, right? If y'all want, you could rewind to see how long it took to synchronize this time. Now we're going to do the same thing on switch 2. Configure router 2 to use switch 2. Go to switch 2 right here. Configure NTP to use router 2's FA00 interface to use the time. So what is router 2's FA00 interface? We're going to say show IP interface brief. We're going to exclude the unassigned IP addresses. I guess that's not supported. So FA00 is 10.10.2.1, right? 10.10.2.1. So we're going to go back to switch to 10.10.2.1, right? Enable. We're going to global config mode and say NTP server. And he said the IP address was 10.10.2.1, right? Now we set him to be a server. We do the same thing on here. Show clock. Still says 1993. While that's synchronizing, it says here allow time for NTP to synchronize on both router 1 and switch 2. Display detailed clock information. Is the time synchronized to router 1? How do you know? So we know that he's synchronized. He's not synchronized yet, right? Because if we do a show clock, he's still not synced. He's still back in 1993 with Marty McFly, right? So let's go ahead and check him out, right? We did show clock. He's in 2019. We say show clock detail. Says here time source is NTP, right? We could do detailed clock information. Yeah, he's NTP. He is still, let's see, he's still in 1993. Yes. If we do a show clock detail, no time source, right? We do no time source there. No time source. No time source. Time source is NTP. You see that? It's synced, and then he says, oh, the time source is NTP. How do you know it's synced to router 1? Well, we know because the time changed. That's one way. On router 2, we're going to go to router 2. Display Ntp Associations. So Ntp Associations, right? What reference clock is being used to synchronize the date and time? What is the reference clock's stratum? So the reference clock is 127.127.1.1. So the reference clock is myself, right? Because we said that's a reserved IP address. But it says here, the master, if you look at this legend here at the bottom, star We have a star and this little symbol right here. That's y'all pop quiz for today. What is that symbol right there? If you know the answer to that little squiggly line right there I highlighted, what is the name of that symbol, the official name of that symbol? So we have this asterisk and then whatever this squiggly line is, or wiggly worm, like my daughter would say, I'm a wiggly worm. Configured, that's what that means. This means that wiggly worm means configured, and the asterisk means it's a master, right? So who is the master? 192.168.1.1. Who is that? Router 1, right? Serial 00. Show NTP status. We did associations on the other guy. Let's do associations. What is the reference clock that's being used? That is the master. What is the reference clock's stratum? The reference clock's stratum is, looks like it says 3 right there. 3 is the stratum, right? All this other stuff, this is like real time stuff. I haven't really researched what any of that is. You ain't gonna get tested on it, but if you want to dig more deeper into that, you do that on your own time. Anyway, what reference clock is on router 2 and switch 2? Display the NTP status and compare the output. So now let's do show NTP status. What reference clock is each device using? What reference clock he's using? He's using the reference clock of 192.168.1.1. Who is that? That's router 1, right? 192.168.1.1. See? So that's that guy. Let's do the same thing on router 2. Switch 2. Show NTP. There it is right there. Status. Reference clock is 10:10:2:1. So his reference clock is this guy, and his reference clock is that guy. So basically, stratum 3, stratum 4, and what does this say right here? Stratum 5. So remember, so he's stratum 5, and we check here, he's stratum 4 and using a different reference clock, right? So his reference clock is him. His reference clock is him because he's a server. Now, if we set him up to be a peer, then his reference clock will be that guy over there. But right now, he is a server. So are the devices operating on the same stratum? No, we've determined that, right? Why or why not? Well, just like we said, because he is a server and he is referencing him as a clock and he is referencing him as a clock. That's the reason why. On switch 1, we're going to go to switch 1 right here. Configure NTP to use router 1's FA00 interface to obtain the date and time. What's FA00 on here? FA00 is 10:10:1.1. So we're going to go to switch 1 and do 10:10:1.1 is the master. Enable, configure, terminal. We said NTP master. Who is the master? 10.10.1.1. What are we missing here, y'all? He's not supposed to be a master, right? What am I thinking? So NTP server 10.10.1.1. You see that? Now, if we do a show clock detail, no time source, right? We'll give him some time to get all that information. We'll go to switch 3 and it says configure NTP to use router 1's same interface, 10.10.1.1, right? So we're going to do the same thing on switch 3. Enable, configure, terminal, NTP server, 10.10.1.1, clock detail, no time source, right? Allow time to synchronize. We'll go back to switch 1 and see if that worked yet. Now time source is NTP. See that? We'll give switch 3 some time there. On switch 1 and switch 3, display detailed clock information, which we did. Is time synchronized to router 1? Yes, it is on switch 1. Switch 3 is probably not yet. Let's see. Show clock detail. Now his time source is NTP. On switch 1 and switch 3, display the status and compare the output. So we're going to go back to switch 1 and do show NTP status. Question is, what reference clock is each device using? Are the devices operating at the same stratum? Why or why not? Well, he is stratum 4. His reference clock is 10:10:1.1, right? So he's stratum 4, right? Because he is stratum 3. Remember? We did that in the very first step of the video, right? We'll do switch 3 and do the same thing. Show clock or show NTP status. He is also stratum 4. Why is he not stratum? If he's stratum 3, stratum 4, why is he not stratum 5? Well, we didn't make him a master. We said for him to get his time through that interface and use that as a reference clock, and he is a master. So, and we didn't change any stratum here. He is getting his time from that guy, and he is getting his time from that guy, and that guy is a master. So that means these guys will be operating on the same stratum, which is one stratum below the master. He is 3, so that means these guys are stratum 4. Right? Y'all get that? So that's why they're operating on the same stratum here. Stratum 4, stratum 4. They're both operating on stratum 4, whereas this guy was stratum 4 and he was on stratum 5 because he is a server and he is a master. That is all I got for y'all today. That is my YouTube page. That is my Twitter handle. Go ahead and add me on Twitter. Go ahead and leave a comment below if you know what that wiggly worm symbol is the name of it. What's the name of it? If you know the name of that symbol, put it in the comments below. Please share this video if you like my teaching style. Please hit the like button when you leave. In other words, comment, like, subscribe to the network.